participants from Jordan, but we also have some guests from Turkey and from Egypt. So welcome to everyone from the region, let's say. The fund was underpinned in Jordan by a memorandum of understanding between BASE, the UK Department for Business, Energy and Industrial Strategy, with the Ministry of Planning and International Cooperation here in Jordan. It is named after Dr. Usama Al-Khalidi, who is a Jordanian biochemist who inspired generations of Arab scientists in the region. The fund covers a range of thematic areas. We funded projects in the cultural heritage, in biotechnology, nanotechnology related projects. We also have energy, water, food, agri-tech projects, as well as big data, as we will be speaking about today. The Newton Fund is based on match funding basis, which means that we have allocations from both UK and Jordanian government. From the UK, we had 6.5 million to support the activities since 2017. And to match that, the Jordanian government, both in kind and cash contribution, allocated 1.2 million pounds for the support of the activities. In total, in the past 5 years, we've supported 70 projects in the different themes and the different activities. In the past year, as a result of the pandemic, we didn't have the luxury of funding new calls or new activities. Therefore, we launched the Newton Khalidi Science Talks. We launched this activity in June 2021 to capture all the success stories and the impact of previously funded projects. Today is the 4th episode, and we have, as we have announced, it is in the occasion of the International Education Day. So today we're hosting a Newton Khalidi funded program, which is the Data Intensive Science Capacity Building Program, a program delivered by Science and Technology Facilities Council from the UK, together with the Royal Scientific Society in Jordan, to support both UCL and University of Jordan to train a number of students, which we have some of them here at AstroJo who are hosting our event, with many thanks to Dr. Ala. And to talk more and to hear more about the program, the design, how it started, and the implementation journey, and some experience from the students. So this is the quick introduction. I will give a very brief biography on our speakers for today, and then we'll leave it to the moderator, my colleague Ala Lizghul, who will be addressing questions to each of the guest speakers. So first we will have Stephen Loader from Science and Technology Facilities Council. Stephen is Head of Innovation and International Development within Programs Directorate of the Science of STFC, a component part of UK Research and Innovation. Stephen, with 30 years of experience working in several UK Research Council, initially is a hydrologist, then focusing on science administration in areas ranging from atmospheric sciences, innovation and commercialization, as well as data policy, evidence and impact, and international development. Stephen has worked in the external innovation teams in STFC since 2015, leading on the development, delivery and management of a portfolio of STFC-funded Newton Fund and Global Challenges Research Fund, the other UK funding program, including initiatives in Malaysia, Thailand, South Africa, India, and in Jordan. Then we have from UCL, Dr. Jonathan. Dr. Jonathan is a professor of physics at University College London and a fellow of the Royal Society. He is a theoretician working on the quantum mechanics of molecules and leads the European Research Council funded ExoMol project, which provides the molecular data necessary for characterizing exoplanets. Dr. Offer Lahab from UCL as well is a professor of astronomy. His research area is observational cosmology, in particular probing dark matter and dark energy via galaxy surveys using artificial intelligence and machine learning methods. He co-directs the UCL Center for Doctoral Training in Data Intensive Science, and he serves as Vice Dean at UCL Faculty of Mathematical and Physical Sciences. You can't imagine the excitement I have reading all of the backgrounds and experiences coming from a physics background as well. So then we will have from Jordan Dr. Ala Azzam, who is assistant professor in the physics department at the University of Jordan. Dr. Ala got her PhD in atomic and molecular physics from University College London in 2013 under the supervision of Dr. Jonathan, who's also here with us in this call, which aims to promote education. She's also the founder of AstroJo Institute, which aims to promote education and research in astronomy and space sciences in Jordan through the connection with UCL in UK and Harvard, Smithsonian Center for Astrophysics in the USA. Then we will have Dr. Giovanna Tinetti. Dr. Giovanna is the head of Astrophysics Group, UCL Department of Physics and Astronomy, the director of UCL Center for Space Exochemistry Data at Harwell. She is the principal investigator of Ariel, the European Space Agency's next medium-class M4 science mission to be launched in 2019. And I can't wait to hear more about that, Dr. Giovanna. We also have in the call, I think we have Dr. Elizabeth joining us, but a thanks to Dr. Elizabeth for helping us facilitating the session and sharing it with the students at UCL. Dr. Elizabeth joined recently in September 2021, the UCL team, and she joined the new Data Intensive Science and Industry Center as the manager of the center. She comes with years of experience in enhancing the student experience. So as I said, finally, our moderator for today is my colleague Ala Al-Zghul, the Newton Khalidi Fund Coordinator, and she will be facilitating the discussion with our guest speakers. Before handing over to Ala, I would like to invite Stephen Loader from STFC for your opening remarks. Stephen, if you may. Stephen,
Okay, can you hear me now?
Yes.
Great, thank you very much. Thank you very much, Muna. Good morning from the UK and good afternoon to all of those of you who are in Jordan and in Egypt and in Turkey. Thank you very much for giving me the opportunity to make a few introductory remarks. I just really wanted to talk very briefly about three sort of intertwining threads: the importance of international partnerships, high-level skills and data-intensive science, and really why this project that we're going to hear more about today is such a fantastic example of those three threads intertwining. Muna gave a very brief introduction to STFC. We're a component part of UK Research and Innovation, the UK's largest public funder of research and innovation. So we support, or STFC supports an academic community of around 1,700 people in ground and space-based astronomy, particle physics, nuclear physics and computing at more than 50 universities and research institutes in the UK. And we also have more than 2,000 staff across several STFC research campuses in the UK as well. And we also have several large-scale scientific facilities used by scientists and industry across a huge range of science disciplines, from medicine to biosciences and energy and the environment. And the other thing we also focus on, or one of the most important things, is the importance of skills. And at any one time, we're supporting around 900 PhD students. So the first of the three threads I just wanted to mention was about in the international perspective. A lot of STFC science is international. We can't do the large major international projects that we do without international collaboration. And one international partnership mechanism that we have used, which Muna did mention, was the UK Newton Fund. And over the past 5 to 6 years, we've supported more than 30 Newton Fund projects across 9 countries, from China to Colombia, India to Indonesia, and then this very important project with Jordan via the Newton Khalidi Fund. And one of the most important common threads across these projects is the importance of training and high-level skills. And we're recognising the huge benefits to individuals and also to country economies that a highly skilled workforce brings. I'll just mention one project that we have funded in a different continent, which is called the Development in Africa through Radio Astronomy, or DARA project. This is led out of the University of Leeds. And this has provided training in radio astronomy and related skills, master's and PhD studies, and high performance computing training to more than 220 students from 8 African countries. And some of these students are now setting up their own businesses based on skills gained through this program. So that's just a very brief view on the value of skills and how it can add value to people, individuals, and also countries' economies. One important component of STFC's strategy and mission is the support of postgraduate skills and talent. The science that we support needs skilled, highly trained people to help advance knowledge and develop new techniques and technologies. And in particular, we need people with the ability to manage and interrogate huge volumes of data to help unlock the value of these data sets. And these skills needed to advance knowledge in these scientific fields are also in demand by the wider economy. So many STFC funded students end up working in the public and private sector. The third thread I just wanted to mention was the importance of data-intensive science. This is a field that's become increasingly important over the last few years. And in 2017, STFC recognised the importance by funding 8 centres for doctoral training in the UK. And these centres involve 19 universities, one of which was the UCL Centre for Doctoral Training that Professor Offer here is the co-director of. And the UCL CDT covers the wide range of data skills needed for high energy physics and astronomy. And I'm sure Offer will tell you a little bit more about that shortly. So STFC invested more than £9 million in these 8 CDTs. And this emphasises the high importance that we place on data-intensive science skills and the need to provide students with a broad and thorough grounding in computational techniques and other issues related to big data challenges. And STFC, we continue to see the importance of this, and we currently are running a second round of centres for doctoral training in data-intensive science, and these will start this coming October. And these centres will nurture the capabilities, talents and skills needed to equip students to collectively address many different global challenges. So on the back of that, we were very excited when Professor Offer came to us with the idea for using the delivery mechanisms in his SEED Centre for Doctoral Training to form a collaboration with partners in Jordan. We were very excited by this prospect. We approached our government department, the Department for Business, Energy, Industrial Strategy, and they themselves also were extremely excited and supportive of this concept. We supported funding. We secured funding of £300,000. Funding was secured by the Jordanian partners, and the result is this exciting and thriving Newton Khalidi Fund partnership, and a model that we think has the potential to be applied to other countries, funding permitting. I think it's also worth just mentioning very briefly that the last 2 years has been extremely difficult for everyone, and particularly with this project and higher education and universities, there's been a huge impact. Universities had to close, and on reopening, the learning environment has had to be adapted to predominantly online delivery. I know from my own family experience that this isn't easy for students. My daughter has just gone off to university and she's struggled. She's found the online delivery is quite difficult. So I totally understand that the challenges that students have faced in this recent environment. However, this particular project has been innovative and adapted to these challenging times, and I'd very much like to thank all of those in the UK and Jordan for working so hard to ensure that this partnership has been able to continue. And STFC is keen to help as much as we can to enable some face-to-face training and collaboration in the project, and I hope that this is going to be possible sometime over the coming year. So just to summarise, I'd like to reiterate my thanks to all of you for joining the seminar today. Thank you to those of you who are closely involved in the running and delivery of this project for working so hard in these difficult times to make it a success. STFC is very strongly supportive of this project and the partnership developed with Jordanian organisations, and I hope I've been able to explain a few of the reasons why STFC see it as such a valuable project. I also particularly hope that the Jordanian students involved in this project are really enjoying the experience, and I very much look forward to hearing more about the activities taking place in the project during this seminar. Thank you very much for your time. Thank you.
Thank you, Stephen, very much. And on the back of what you just mentioned and the efforts of Dr. Ala and Dr. Offer for continuing this program, I just wanted to share when we started to contact the programs at the start of the pandemic, which was a horrible time for everyone. I remember Dr. Ala's Plan B, which was immediately taking place with the restrictions, dividing the large group of students into tens, just to deliver the same training to everyone else. So huge thanks for your resistance, for your resilience, I have to say, through the pandemic, and for showing a great example. And speaking of the students, they are joining, and I want to just spotlight them for everyone to see them, but they are here joining, and as you can see, so they are here. There seems to be interested. I hope so. We had a really interesting info session with them earlier. It was really a great opportunity to speak to them, to know their interest and what they're looking for. So hopefully we will continue supporting that within the embassy as much as we can, and with the opportunities that we will be having within the embassy. So with no further ado, I will hand over now to my colleague Ala, who will be moderating this session and starting with a quick intro on the International Day of Education. Ala, over to you.
Hello, hello everyone. So let me start with a brief introduction about the International Day of Education. Education is a human right. Therefore, the UNESCO proclaimed the 24th of January as the International Day of Education in celebration of the role of education for peace and development. This year, the UNESCO will celebrate the 4th International Day of Education under the theme Changing Course, Transforming Education. And therefore, we will use this platform to showcase our Newton Khalidi Fund program, Capacity Building in Data Intensive Science. So allow me to start with our first speaker, Dr. Offer from UCL. Dr. Offer, would you please tell us about the research and industry stage of the Data Intensive Science program? We would like to know about the successes, challenges, and your recommendations. Over to you, Dr. Offer.
Sure, thanks very much. I'll try to put the right.
If you have any problems uploading the PowerPoint, I can do it from my end.
Yeah, please do try.
Okay. Okay, we can see your PowerPoint.
Can you see it now?
Yeah.
Very good.
But if you can click on the display. Yeah.
Is this my version now? Yeah.
Yes.
Okay, very good. Well, it's a great pleasure to be here. It's a very special occasion for us, really a milestone in this endeavor. I would like to thank the British Embassy, Muna and Ala for setting it up, and of course Dr. Ala Azam, and all the other participants, STFC, we just heard Stephen, and also participants from Turkey and Egypt. So this is just a brief summary of where we stand on this program, which sort of started 2019 or so in data intensive science. I've noticed putting a picture of UCL, the main cohort, and a picture from Petra, that the architecture is somewhat similar. Maybe it's a topic for another study, how they came up to be so similar. In any case, I'm here representing the CDT in Data Intensive Science, which I co-direct alongside Professor Nikos Konstantidis, and also this program, which I co-lead with Professor Jonathan Tennyson. And I'm wearing another hat, which is Vice Dean International, so which is obviously about connecting UCL to other countries. So this is a shining example of that. The next slide, it shows you the concept of our CDT. Sorry about all these acronyms, but that's Center for Doctoral Training in Data Intensive Science, DIS. And if you like, you can think of it as a triangle. You can think of the logic of the concept as a triangle. The most important participants in this triangle are the students. And by now, we have over 5 years, we have 53 PhD students. In fact, 8 of them already submitted their thesis. And then they've been supervised by 80 plus academic supervisors from different disciplines in 6 departments. And in addition, the students spend time in the industry doing group projects as well as actually placements of 6 months. We'll hear more later about the training from Professor Jonathan Tennyson, but we have about 30 industry partners. So the concept is that we are preparing students for a dual career, okay? So they can, on one hand, do projects on one of those big, usually connected to these many different facilities. Say in astronomy, it's all the way from planets, and we'll hear more about it from Professor Pivantinetti, to using the CERN as particle physics devices, but also some other topics in theory and so on, other fields. And at the same time, they work closely with those companies here, which include a very wide range of topics, of practical research. It could be the oil industry, or a fashion retailer, or a media agency. So really, they bring it together and they enrich. I believe they enrich both us at the university when they come to us back with ideas from the industry, and it also enriches the industry. We'll hear later about 2 of our students about their own experience. Konstantina and Paddy will actually tell us what it's like to be a student in that program. And of course, astronomy and particle physics are very natural platforms for this, because we always have sort of lots of data, and it's increasing and increasing and increasing. And for example, this is just an idea how you would like a computer to classify a galaxy, to tell us if it's spiral or elliptical, not just doing it visually, because there's so many galaxies to look at. So in the old days, when I was a student, people actually looked by eye to tell if it's a spiral or galaxy, but at that time there were only thousands of galaxies. Now projects we're involved in, like Dark Energy Survey, have got 300 million galaxies, and the new projects such as SKA, Euclid, LSST, in which, by the way, STFC is fully engaged, would produce billions of objects. So there's no way you can do it just visually. And that's just an example from extragalactic astronomy. Of course, the same is true in other fields of astronomy and particle physics and many other areas. You can see more about the CDT in this website at the bottom of the slide. And incidentally, this is a summer school we held at UCL at 2018. We invited students from all these 8 centers that Stephen mentioned, and this was a big success. And you can even see the sky was blue for us. And we very much hope to have a similar workshop. I hope we'll be able to meet in that place with the Jordanian students. Then we recently, given the success of the CDT over the past 5 years, we've upgraded it recently with support from the provost, the head of UCL, and we appointed 2 lecturers and a postdoc and a manager, Dr. Elizabeth, who is on the line. And we call it Center for Data Intensive Science and Industry, DISI. And now the CDT I talked about in the previous slide is one element of it, but there is also another element, which is a very successful MSc program. We'll hear about it later. So this is, if you like, on the training side of those 2 degrees, but at the same time we have the links with the partners, We have, as I mentioned, group projects, placements. We also have mini fellowships. And we are very keen on extending our activities internationally. And this project with you, with Jordan, is a great example, and we hope to extend it in the future. And of course, all that is linked to direct research by postdocs and research software developers and visitors, seminars and workshops and so on. So this is our new scheme there. Now, in terms of this, the Newton Khalidi UCL Jordan program, so as mentioned earlier, the idea was to somehow use the knowledge and processes we've developed at UCL and to extend it. And I myself have a personal interest in the Middle East. I think it's a region with great potential, and just with a bit of capacity building, I think it could become a fantastic hub for data science and other disciplines. And as really, it's absolutely fantastic that Dr. Al-Azam, who got a PhD from UCL, has taken on that role of leading that team. And I'm very impressed by the way it's organized at the other end, despite the COVID situation. And also, we are very impressed that about 60%, if I got it right, of the participants are female, which is absolutely fantastic. We're trying very hard in the UK to have a good gender balance, and here you are a great example of that. And it was mentioned earlier by Muna and others that you have many other you have the motivation to develop the priorities, national priorities of Jordan in health and energy, water, environment, and other areas. And actually, data science is perfect for that. I mean, the same programs we use to analyze galaxies and particles in an accelerator can actually also be used to analyze such issues as water, health, COVID, etc. And in fact, our students have been engaged in some of these activities, including in COVID research. Some of you were online, and some even in person in the launch launch event on the Jordanian side in February 2020, just when COVID came to the world, and then we had one in April. So as already mentioned, our big challenge is to carry on and to carry on the activities despite COVID and to think ahead. So STFC and BASE kindly given us £300,000 back in 2019. And this was matched by a generous in-kind contribution from Jordan at the level 260K. I've listed there the Jordanian institutions that are involved: University of Jordan, the Astrojo Royal Scientific Society, and the Princess Sumaya University of Technology. And we had really to use online, so there is a course in machine learning devised by our colleague Jason McKeown, which is very successful, a lecture course by Giovanna Tinetti. And we also, Jordanian students participate in our monthly seminars, but we wish to extend it when we had a discussion just last week on really try to actually have a summer school in person and some training workshops, and to have exchanges of staff and students, and also to have the students participating in placements in companies, and we have just to, as the politicians like to say, there's plan A and plan B, and we have to be prepared for either face-to-face, which would be ideal, or virtual. We hope to extend it, given that with the help of STFC, hopefully to end of March 2023. So hopefully things will get better. And our long-term aspiration is indeed to do something across the whole of the Middle East. It's great to have these representatives from Egypt and Turkey on the line, and we can also think of other countries in the Middle East who could participate. And we have this very nice example of Sesame, this light source facility in Jordan, which brings together people from all over the Middle East. So thanks very much for the organizers. Thanks for the participants. And I look forward to, a happy and healthy and fulfilling 2022 in this program. Thank you.
Thank you very much, Dr. Offer. Thank you for this great presentation. I would like to remind everyone to write down your questions, as we will give a space at the end of the session for Q&A. So now let's please welcome our second speaker, Dr. Jonathan, who will tell us about the training program of the Data Intensive Science at the UCL. Over to you, Dr. Jonathan.
Hello, can you see my screen?
Yes.
Yes,
Okay,
we can see it.
Okay, fine. All right, with you in a second. So, good day, everyone. I'm director of the MSc in Scientific and Data Intensive Computing, and also in charge of the training program for the CDT. So what I'm going to do is just very quickly tell you what training we deliver as part of this, just to give you an idea of how we try and train our students, both in skills related to the scientific research they want to do and in general data intensive science skills for analysing a lot of problems. So I'm going to talk about both the MSc in Scientific and Data Intensive Computing and the Centre for Doctoral Training in Data Intensive Science. And the first of these was the MSc, was originally called Scientific Computing, and we added a data intensive stream to it. It's a 12-month program with approximately 80 students, and that's capped because actually it's proved hugely popular. The number of applicants we've had have gone up over 2 years by a factor of 5, and my email is now on a daily basis, and today is no exception, full of very upset students who I've not offered a place to on this course, saying why they really want to come on the course. So this is quite challenging for me, but it's nice that we can actually have the pick of students. The majority of students who take this course are not UK based. We have maybe about 20–25% from the UK, and we take students with a first degree in a wide range of subjects: physical science, mathematics, computing or engineering. And the idea is to embed computing and data science at both a formal and a practical level. So we have a range of courses, and I'll show you some of the courses in a minute, which teach practical skills such as programming, but at the same time, numerical methods, model building, optimization. And similarly on the data intensive science, we have the theory of statistics, of data, and practical machine learning. And as I said to you, this is in high demand from students, and equally our students, when they graduate, are in high demand both academically to do PhDs, and PhDs quite often in subjects that they've not studied previously, but are recruited for their data science skills, and in industry where data scientists are hugely required. So the curriculum involves 3 parts: core courses, which all the students take, some optional subject-specific courses where you choose courses related to your first degree and also the research project you're doing. And then the final third of the MSc is spent doing a research project with a wide range of topics, basically anything in the areas I just said first degrees come from. We can also have a research project. The only unifying feature of these research projects is they must contain an element of programming, and 20% of the mark on the research project actually goes on the program that's developed as part of the project. That program does not have to be standalone. In the modern world, it's very often that you write new modules to go on an existing program. That is also entirely acceptable, but you must write some programming. So the core courses we offer are in computational and simulation methods, numerical optimization, research software engineering with Python, also known just as Python, research computing with C++, normally just known as C++, techniques of high performance computing, machine learning with big data, and statistical data analysis. And there are 8 courses there. The students have to take 6 of them. They can take all 8 if they want, but normally they take 6 plus 2 other optional modules. And as part of the Newton program, what we've done is we've provided the machine learning with big data and the physics of exoplanets as remote learning courses. We took a very fortuitous decision this time 2 years ago before COVID hit, that we would video the machine learning with big data course. And this turned out when everything went a bit pear-shaped and we couldn't travel anymore because we originally managed doing a lot of in-person workshops, we were able to provide this course as a set of videos with tutors from students on the CDT who had taken the course. And more recently, we provided the Physics of Exoplanets course in the same way. The Centre for Doctoral Training is something that's now quite common in the UK, though this is the first example run by STFC of a cohort approach to PhD training. So you group PhD students together, which gives an opportunity both of providing training program and also recognizes an awful lot of research training is not just learnt from your supervisor, but it's learnt from the student sitting on the desk next to you, so that you build a cohort and these cohort can interact very productively together. It's a 4-year program, and much of the first year is spent with intensive training, and I'll talk briefly about that in a minute. There's strong engagement with industrial partners, and one of the major successes of the current CDT has been its ability to engage with industrial partners, and the sheer number of industrial partners who wanted to climb on board, to the point we've actually had to turn people down because we could only guarantee serious interactions with so many industrial partners. And the interactions with industrial partners are twofold. First, a group project, which I'll come back to in a minute because that's done in the first year. And then later on in year 2 or year 3 of the PhD, there's a 6-month internship in industry, which is not part of the PhD program. And that has proved very interesting for many of the students. And we've had now quite a number of students complete their internships. The CDT has been training between 10 and 12 students per year. That's 53 so far. We've just started the 5th cohort of students this year. So the training for the Centre for Doctoral Program is heavily modelled on the training given in the MSc program I just talked about. And the first year training has about 150 hours taught material, including 3 of the courses I just talked about, the Python course, statistical data analysis, and the machine learning course. And then you do specialist training, so typically 60 hours in high energy physics or astrophysics or some other subject specialist topic. These are assessed by light continuous assessment. There's then a 4-month group project with industry where groups of students are divided up to solve a particular problem identified by the industrial partner. Some of these have been extremely successful, actually led to publications, and indeed in one case a prize at a conference when it was presented. And then during the remainder of the CDT period, there are a number of one-off training events that are spread over 4 years. They can be things like data security, which is normally needed before the group project, ethics of data, entrepreneurship. There were, before the world went COVID-like, a number of summer schools, so students could expect to go on a summer school during the CDT, and hopefully that will come back again too. So that's my quick whistle-top tour through the training we offer at UCL in this area, and gives you some of the idea of how we've tried to integrate this with the Newton program. Thank you very much for listening.
Thank you very much, Dr. Jonathan. Thank you for sharing your experience. And let's move to our next speaker, Dr. Giovanna. Dr. Giovanna, would you please share your scientific point of view of the data-intensive science program? Over to you, Doctor.
Absolutely. I will try to share my presentation.
Just a quick note to Dr. Jonathan, we still can see your desktop, so maybe you need...
Oh, right. Sorry,
yeah.
I thought I'd stop sharing. Sorry about that.
It's okay.
Is that better?
Yeah.
Okay. So I'm trying to share my presentation. I'm not sure.
We were able to see your desktop.
Okay.
I mean, a second ago, but now we can't.
Let's
so maybe
see. Try again. Can you see my desktop now?
it's uploading. Yes.
Can you also see the presentation?
Yeah.
Sorry, because all of a sudden I am unable to see what I'm projecting. I'm so sorry. Can you see it now? Okay, perfect. So good morning and good afternoon to everybody. It's a great pleasure and an honor to be here with you, and I look forward to meeting you in person very soon. So exosolar planets are very new subjects, and it's only since the 90s that we have discovered that other stars are actually hosting planets. And we also learned that planets are ubiquitous, and statistically speaking, we're expecting at least as many planets as stars. So it means that even just in our own galaxy, we're expecting to have billions of planets. At the moment, the number of confirmed planets is about 5,000, but many more are being discovered because of a long list of facilities from the ground and space. We know still very little about these exosolar planets, these mysterious worlds that are orbiting other stars. But for some of them, with current instrumentation, we are able already to capture some of their chemical composition. I'm showing you here a result that was obtained by my team at UCL in 2018, when we look at this particular super-Earth that was orbiting the habitable zone of its parent star. And we could see the signature water vapor. And so that was a quite exciting result. So I think for all the students and for all the young people is really an incredible period if they're interested in exosolar planets, because we have all these facilities that were launched and are currently operating, or it will be launched very soon in the future. But also many facilities from the ground. And so this is really a global interest, a global endeavor, because there are now facilities to discover, but also to study exoplanet really in many places in the world. And of course, because we are combining the fact that the number of exoplanets is increasing exponentially, so big number of objects, with the fact that the kind of signal that we are trying to extract out of this planet is very small, typically part per million of the star. That explains why we really need to have very sophisticated techniques in order to do this kind of observations and analysis. And artificial intelligence is really extremely valuable as a tool really to extract the signal out of exoplanets. At UCL, we really worked a lot, we have pioneered many of these techniques using AI, and in particular, many of the students and postdocs were trained through the UCL CDT, and this has been an incredible resource really to train people not just on exoplanetary science, but also on artificial intelligence technique in order to really observe these objects. All our tools are all open source, so if anybody is interested anywhere in the world to use our tools, they're all on GitHub. And it was really extremely helpful to have recently the hire of Dr. Ahmed Arafai, because it's really helped to convert all our development code into a very professional open source code. And so now anybody can really download all this code out of our GitHub. A few words about Ariel, that has been adopted by the European Space Agency to be the very first dedicated mission to study the atmosphere of exosolar planets. And in particular, Ariel will be launched in 2029, and will look about 1,000 exoplanet atmospheres. So we will look at the chemical composition, the temperature, and the characteristics of these worlds. An area will be built by a consortium of 16 ESA countries, but also the contribution of NASA and JAXA. And UK is leading this mission and the principal investigator. And the entire payload will be assembled at Raleigh Space in the Ariel campus. So we have really a fantastic opportunity to see Ariel being built. But of course, what is also extremely interesting is not just the instrument, it's also the data that Ariel will deliver. And because we will aim at, again, extracting very small signal out of a long list of targets, that's where really AI is particularly useful. And that's why we are launched since a couple of years the Ariel Data Challenges, in collaboration with UK Space Agency and, of course, CDT and DIS at UCL. And this has been really a very successful initiative. And in the past machine learning data challenges, the one that we launched in 2019 and 2021, we had more than 100 international teams of professional and amateur astronomers, but also amateur machine learning professional and amateurs. And they all participated and really helped us finding some new techniques in order to extract the signal out of some simulated data that contain a lot of noise due to the star, but also to the instrumentation. So we'll continue with the AI Data Challenge in the future, given this great success. And we hope that more people will be able to participate in the future. There will be one launch in 2022. Also, more in general, if students are willing to really participate to some of the observations, you don't need to have big facilities from space to do that. You can still have a really small amateur type of telescope in order to do some very interesting science. And the ExoClock initiative, in collaboration with amateurs really from all the world, has been really a global success because it's including the participation of both professionals, but also schools and many amateurs. They're all helping to monitor the ephemeridis, or the position of the aerial targets, and has been really, really a great success. So I'm conscious of time. So the message that I want to pass today is that exoplanet is a new subject, but very successful, in particular because there is a growing number of exoplanets being discovered, and we still know very little about them. And so I believe it's really a great opportunity to attract new, bright, young students who want to contribute significantly, because they can still bring a very novel and fresh contribution, and they can recognize for that. And I believe the new course for about the physics of exoplanets that I'm teaching at UCL has been a great success among students, because the subject was something that we're very interested about, very interdisciplinarily, and it allows to teach both planetary science, stellar science, but also is a great opportunity to teach AI techniques, because these are really critical to extract the small signal out of the stellar noise. Exoplanetary science is, and I believe will continue to be, a global endeavor. And I really hope that we will collaborate even more in the future, and look forward to meet you in person, not just on a screen. Thank you very much for your time and attention.
Thank you very much, Dr. Giovanna. And actually, it's really great that you shared that this opportunity can be available for young scientists, especially that we do have a lot of them here today with us, and they are really interested in such a scientific example like about exoplanets. So thank you very much for sharing this scientific example. And I think we will have some other questions to be at the end of the session from some of our students who are attending today. So thank you very much. Now, we will move to the University of Jordan with Dr. Ala Al-Azzam. So, Dr. Ala, from a Jordanian implementation perspective, could you share with us, like your students' recruitment process, the beneficiaries' involvement, and your experience in the training program with the Jordanian students? So, over to you.
Hi, it's my pleasure to meet you all in this science talk, and especially in this day for education, which is a good example to tell the people about our program here in Jordan in collaboration with the UK, especially University College London. In fact, we began from an email sent by Jonathan and Offer to me, asking me about, is there any chance to deliver this program to Jordan? And in fact, the proposal was designed for 60 students. They had to have a master's degree to do this, or to have the chance to get this program. from my experience, in fact. And I asked Jonathan and Offer if there any chance to make the program delivered to much more than 60 students. They asked me how much. I said, okay, let us see. We together will design the criteria for the program that we think it is the best criteria that we need for the student to begin with. Then I will make the announcement, and let us see how many students we will get. In fact, they didn't mind, and we redesigned the program for this criteria. In fact, I'm happy for our friends from Turkey and Egypt to be with us today. Maybe that will help them in the future if they would like to perform this program or something like it in their countries. In fact, we said we want the student to have good English language, because the communication will be in English language. We are in need for the student to have any program language that would help. Also, they have to come from scientific backgrounds. We don't mind if they are even in their bachelor degree, as much as they have the criteria that we want. In fact, we got like 45 students from different universities in all Jordan. As Offer told you, in fact, the female were like 26% of the participants. And we began the program. Then we had this COVID-19. It was an issue for all the world. So we were in need to deal with the situation, with the new situation. Now, basically, the main challenge was that we didn't manage to do any training face-to-face. This is the most major problem, and even the training for the students. We began training for students the last year. In fact, they began online with their colleagues in UK, but at the end we faced that problem that they had to be in London because there are some rules or something that they didn't manage to solve. So this mainly the major problems, let us say. Now, because we got the extension up to 2022, we expect maybe in this year we can manage to do the face-to-face training, hopefully. Now, the point is, maybe because of this extension, some students had to quit from the program because their lives or they have some issues in their lives. They didn't manage to continue with us, unfortunately. So now we have 27 students, which is much more than what the program began with as a proposal. So still we have 60% females. Okay, so the females are still much more than males, and we are happy with the males that we have. Okay, and all the males are welcome also in the future programs. But anyway, now the thing is, I'm really very grateful for Professor Jonathan and Dr. Offer to trust us and to decide to begin their program here in Jordan. And I believe that in two things. I believe in our students. I know they are very keen to finish the program until the end. And I believe in my colleagues in UK, in UCL, Offer, Jonathan, Giovanna, all of them, all the people, because they are following us all the time to be sure that we are implementing the program in the best way that we can. In fact, maybe the thing is, it is an advice for our colleagues in Turkey and Egypt. It is always you have to plan to have plan B and plan C. We don't know what would happen. It is just to get the best of the program. That which we call it is which we consider as a chance, the very big chance for our students to get trained by experts from UK through this program, and especially from University College London. That all. Thank you, everybody. Thank you. Thanks, Ala. Thanks, Mona, for this chance. Thank you.
Thank you very much, Dr. Ala. Actually, what attracted me really that you mentioned that how this opportunity started with an email. So I'm really going to go back to all my unopened emails to make sure that I didn't miss any other opportunity. This is really great how you mentioned that, and how you're very passionate in talking about your students. And I really, really feel proud to work with someone like you. So thank you for your time. And now we will move to the success stories, starting with the students from University College London, and then a few students from the University of Jordan. So I will direct one question to each one of you, so you can think, and then I will mention each name to start with them. The question is, would you please share with us the best out of your journey with the Capacity Building Data Intensive Science program? So we will start with Konstantina. Over to you.
Hello, everyone. Let me share my slides. Can you see my slides?
Yeah, sure. Go on.
Perfect. Thank you. Hello, everyone. My name is Konstantina, and I'm a final year PhD student in the CDT in Data Intensive Science at UCL. I will talk very briefly about my CDT experience, what my PhD project is about, and the opportunities that the CDT has offered me beyond that. My PhD project is under the supervision of Professor Ofer Lahab, and it is on the topic of gravitational waves. I worked on estimating the expansion rate of our universe using gravitational waves. And our work was published in the monthly notices of the Royal Astronomical Society journal. I have also worked on using machine learning for the detection and classification of simulated gravitational waves injected in real noise data. In my first year of my PhD, as part of the CDT program, I undertook an industry project with the CDT partner company called ASOS, and this is an online retail company. And I worked on building a classifier using natural language processing techniques, which would be integrated with the company's chatbots to label queries received by customers. Our work was accepted at an IEEE conference in Spain, which I had the opportunity to go and present our work, and we received an award for Best Paper. More recently, I have also completed a 6-month placement at a company called Faculty, where I worked on improving the algorithm that the company was using for detecting anomalies in datasets. And being a student of the CDT offered me a variety of experiences. The initial training offered by the CDT, as Professor Jonathan previously mentioned, offered me with the knowledge and the skills to that were useful both in my PhD project and my industry projects. And it has also given me the opportunity to be involved in this program and to help deliver a machine learning training course to the students in Jordan, which was a very positive experience for me. And although the industry and PhD projects are on different topics, the skills and the tools I developed in one project were effectively used in the other. Thank you very much for your attention.
Thank you very much. Thank you, Konstantina. So now with the same question, moving to Patrick. Over to you, Patrick.
Sorry, shared the wrong screen. Let me try that again.
Yeah.
There you go. Okay, so I have not been as organised as Konstantina, but I have some tabs open. So yeah, so my CDT experience, so I was part of the first cohort, so I think I'm the year above Konstantina. And as of 2 weeks ago, I have handed in my thesis and awaiting my Viva, which is exciting. So yeah, similar to Konstantina, I'd had similar kind of experiences. So my group project, which I undertook in my first year, was with a company called MCC Group, who what they do is called ethical hacking, which is basically where companies will hire them to try and find vulnerabilities in their network or in their databases or something like that. So we were basically pointed towards a huge database from Los Alamos National Laboratory. I found our report from 2018. And anyway, we did various things. So example, like trying to see how all computers were communicating within this huge network, visualizing, picking out through some machine learning, what we thought were intrusive events, such as like password spamming and other things like that. And yeah, some other classification. My placement, I did a company called Vortexa. So Vortexa are basically interested in tracking energy markets throughout the world, primarily focusing on shipping data. So here are examples like a picture of their platform. So they have like, all boats everywhere, and trying to work out, do they have crude oil? Do they have naphtha? Do they have some kind of byproduct? And through this, they can basically help traders to work out where's best to invest. And so my job was helping to ingest this huge amount of data and come up with some simple predictions that their investors or people using the product could use for their own thing. On the academic front, so I have 2 papers submitted, both to IEEE, which is electrical engineering, so a little bit less astrophysics, but and here's like a sneak preview. It's not really much. So I use a tool called wavelets, which I use for signal processing. And for an example, here's a data set where, so this is focused on South America, and the idea is data exists just within South America. And how can you, for example, denoise the data in a clever way? And this is an example of how we did it. And finally, yeah, there's a sneak preview of my thesis, which the date is actually 7th of January. But anyway, yeah, in hopefully 2 months or so, I'll have my viva, and then that'll be that. And yeah, lastly, yeah, I helped teach the Jordan course last year, which was a great experience. I also taught with the main UCL cohort as well. So yeah, I've done lots of that course. Anyway, thank you for listening.
Thank you very much, Patrick. Thank you for your time. Now we will move to the University of Jordan students. So just to mention that the University of Jordan students are from the bachelor degree, and we will start with Ibrahim. Over to you, Ibrahim.
Good afternoon and good morning to all of you. My name is Ibrahim Al-Masri. I came from IT background. I've been accepted on the DIS program since 2 years back. Since then, we have learned many things and we have done many activities. We have given many lectures to the community and awareness session in space science and artificial intelligence. For me, the most exciting thing is that last year we've completed a machine learning course, and we've learned the science and statistics behind it. It was advanced, useful, and very tough one. But it gave me the ability to introduce a new business line in my current employer. I'm working in as an IT system integrator, and I've introduced a new services to our clients to analyze and visualize their data, aiming to assist the decision maker to steer their businesses. Thanks to all of you and your contribution, and thank you to Dr. Ala for facilitating all of this. Thank you all.
Thank you very much, Ibrahim. Thank you. Now we will move to Lian. Over to you, Lian. If you can unmute yourself. Yeah, now we can hear you. Go on.
Hey, how are you all? Good afternoon and good morning. I didn't actually prepare anything. I thought I'll just talk about the story and the journey that I had in this program. When I first started at this program, I didn't actually know anything about data science. Coming from a physics background, I honestly thought it's something just geniuses and very talented people study. So when I started studying it and taking all of these information, I understood how important it is, and the fact that we can actually simplify it and learn it. And that's what made me incorporate all of this in teaching. I love teaching school children and young people. So I took everything that I've learned, tried to simplify it as much as I could, and then teach it to school children. We launched a program in machine learning and data science with the help of Hashtag, which is a great institution that teaches school children all about tech and technology. And I remember that at the end of the program, one of my students came up to me and said, wow, I thought that data science is something that I would never learn because it's so complicated. And that's the same feeling that this program gave to me. So I was so happy, and I'm looking forward to continuing learning and teaching all about it. Thank you so much.
Thank you for your passion, Liam. Thank you very much. So now let's move to Asil.
Good morning and afternoon. In a lot of time, I ask myself, do the stars look at us the same way we look at them? I hope that. We look at the sky as it is contents of all the dreams and secrets. We are started from the Astrojo learning learning about data science, especially in machine learning, and mix it with physics. My name is Asil, and I come from background of physics. In the first lecture, after the first acquaintance in the audit room, we start to learning the machine learning. The first programming language we start learning, it was the Python. We started from printing hello world to reach the highest list of the programming. In Astrojo, we learning how we can work in the team and exchange the experiment with together. Dr. Ala Al-Azzam was the model of the girl, Arabic girl, that do anything to go for God. I thank hers, and I thank my friends in the Astrojo. And thank you.
Thank you very much, Asil. Just to mention something, that Asil came to the training from a very far place in Jordan. So when she assigned herself to the program, she used to go for at least 3 hours for the training to take this training. So thank you for your passion, and thank you for doing that. So just at the end, I would like to say thank you very much for all of our speakers and for the students for sharing their success stories. And now over to my colleague Munash, who will be handling the Q&A questions.
Thank you, Ala. Thank you for all the speakers and the students. You left us in wow, what is this? So it was really interesting and exciting to hear from you all. I have only one question in the chat bar, but I will invite and encourage everyone, if you have any further questions, please do put them in the chat bar, and or raise your hand and we can take all of your questions. So starting with the question of Dr. Ashraf for Stephen, Jonathan, Ofer, and all of you who were in the academic field doing the research. I think accessibility to resources is a big challenge in Jordan. So I don't know if you had this back in the time in the UK, how did you overcome this? But the question is how to overcome this challenge to be able to disseminate this type of knowledge and this type of research to the public, because accessibility, especially to such a new and very limited resources that we have in Jordan, it will be very difficult to be able to conduct the research, use the resources, and be able then to disseminate that. So any advices on how to overcome these similar challenges? The question in the chat is addressing Stephen or Ofer, but I think it might be open to anyone from the speakers. If you have any advice, tip on how to overcome the challenge of accessibility to limited resources.
Okay, well, I'm happy to start. I mean, but just to clarify, is the question about how to make data science more popular to people?
More popular? more popular, but with the challenge that accessing the resources like stimulation devices and any learning resources are very limited and are not open for use by anyone.
Okay, well, I think the good news now is that everything is so accessible. There's all this open access to facilities, and you know, I got interested in AI for astronomy 30 years ago. Everything was very limited in terms of resources. Now there are actually packages on Google. You can actually go and just, for example, Google Colab is a particular facility. I'm not working for Google, by the way. I'm not doing any advertisement here, but you can actually run codes in Python for free, just online. You don't even have to download it or to buy it. You can just run it. And I see, you know, my 13-year-old daughter is now learning Python at school, and they just use all this open access to do that. Okay, so in fact, anyone in the world has access to the same facilities. Of course, sometimes the commercial companies charge more if you want to use larger data sets and storage. So point number one is really that quite a lot of it is accessible. Likewise, data sets in astronomy are open, right? We are obliged by our funding agencies, whenever we have a project, within a year to release the data. So anyone in the world can actually access the data, right? But of course, some data are, you know, nicely presented, more nicely presented than others. But then, you know, one can help with that. And finally, I think AI is everywhere. It seems to me that people are now, you know, in every iPhone, you have AI, right? You can click on your set of photos on your iPhone and put a word, and it would find, you know, all the photos that have dog. You put the right dog, and it will find all the photos that have dog, but it also makes mistakes. Okay, I tried it. It makes mistakes. So it also shows you that AI is not perfect, and one has to be actually very careful on using it in terms of getting biased results. So I'll stop here, see what others think.
Yeah, can I make a comment? Yeah. So just to amplify a bit on what Ofer said, the whole open access area in science is growing very fast. So for instance, from April in the UK, we're going to have to, it's now become codified that we publish all our papers, that they're open access and accessible to people who can't afford journal subscriptions. Similarly, it is now normal to place all programs in places like GitHub with an open access compliant thing. Now, some of the more ambitious machine learning stuff that you read about from Google doing whatever, use huge computers. But the reality is I'm a newbie on machine learning, not like Ofer, who's been doing it all his life. And the machine learning my students are doing are just done on the sort of laptops you've been following this presentations with. They're not that computer intensive. They only become computer intensive when you use a huge amount of data. So that I think it is actually, it takes persistence and you have a barriers to understand and to get over. But I think there is a lot out there that people can access from Jordan or from, you know, people who are not in the university and in the UK similarly.
Yeah, thank you. Thank you both for your contribution. I don't know, Jonathan, if you finished your answer or you were interrupted.
Yes, I have. Yeah. No, okay, I finished.
Great. I hope this answered your question, Dr. Ashraf. But to make the best of our time, I have Raed or Raed al-Zu'bi raised his hand. Yeah, please come in for your question.
Thank you all. Thank you, Muna, and thank you for inviting Khalidi and for the speakers as well. Well, I'm Raed al-Zu'bi. I'm Library Director at Jordan University of Science and Technology. 14 years for now. Before that, I was working in IT infrastructure. Well, I have something a little bit to add about data and big data challenge, which is the fair concepts. I know that is open access, but it's a challenge if we are accounting for individuals to get their own data shared or findable by others as individuals. So I'm not sure if there is a kind of efforts or planning to adopt the FAIR concept, in the library on open science and in general, to be findable, accessible, and interoperable and reusable. There is a need to follow standards to adopt open access repositories and to ensure these data sets and all scientists all around the world to have benefits from data from each other. Thank you very much.
Thank you, Raed, for that comment. I think this is globally, this is applied, the FAIR approach on research and on open data. And especially when you're publishing on certain journals, that should be like a criteria to be considered in your publication. I don't know if any of our guests would like to add anything to Raed's comment. It wasn't a question, Raed, right? It was more than a comment encouraging.
It was a comment and a kind of a question if there are a kind of initiative, since our distinguished speakers are scientists and are running a kind of research community in UK and the region and maybe worldwide. So as you mentioned, when publishers by themselves for open access publications, they adopt the standards. But when you own the data and you are interested to make the data sets, the raw data itself be shared among scientists worldwide. I'm not sure if there is a kind of publisher or commercial entity that, but to be honest, when you talk about open science, you need to adopt your own publishing infrastructure.
Can I
please
comment? So firstly, I would strongly support your advocacy of FAIR. I think it's completely the way science should go. UCL itself has a very strong FAIR policy and has tried to take a lead on this in the UK. And to advertise shamelessly, I've just become editor-in-chief of a journal published by the Royal Astronomical Society, which is quite interesting because this society is very old and it's only their third journal. So they start a new journal once every century. And this is called RAS Techniques and Instruments, and it's very much embedded on FAIR principles and machine learning, numerical methods, software development, as well as work to do with instrumentation are the core of this journal. And the idea is to provide a vehicle where people can provide all their techniques that underpin their science, as well as just their normal scientific results that people publish. So that journal is going live in March. We're already taking submissions. I'd be very happy to talk to anyone who's interested. But I just want to echo that I think the future of science is about sharing one's data and one's programs and one's results in full.
That's very useful. Thank you so much, Jonathan, for sharing your experience. I have two more questions in the chat bar. So Ala, my colleague, is asking Dr. Giovanna, how can we make a good use of the open resources related to the exoplanet data in Jordan and the Middle East?
Thank you so much for your question, because I think it gives me the opportunity really to say a little bit more about this. Certainly sharing the course that I did at UCL is just the first step, because it allows students to have some of the basics about exosolar planets. But then actually, if they want to work on data, as Ofer said, luckily in astrophysics, most of the data coming from current telescope are available after a few months or 1 year maximum. So all this data can be accessed by anybody. So the data for Hubble Space Telescope, for instance, that we have been using throughout the years will be similar also for the James Webb Space Telescope, will all be available. And as I mentioned, we have built all this infrastructure of open source tools that can be used to analyze those data. So of course, these open source tools, anybody can look at that, is on our UCL GitHub for exoplanets. I'm more than happy to share the link throughout my presentation. But more in general, if you want, we can organize perhaps a more specific, a bit more advanced workshop where we can show you how to use these tools with current data and also with future data. I haven't mentioned the fact that ARIA will have an extremely open data policy. The tier 1 data, which are the data for the majority of the planets, will be available immediately to the public without proprietary period for the consortium. So anybody in the world will have the opportunity to do that. And so that's why we're organizing all these data challenges. We want to make sure that the scientists from all over the world will be prepared to receive this data and be as competitive as anybody else.
Thank you very much, Dr. Giovanna, for answering the question. I have one final question from a friend and the founder of the Robotics Academy in Jordan, Lama Shasha'a. So Lama is asking about the impact of involving children in such fields. So she's asking, can we collaborate to make the children have a taste of those cool fields early and have them engage with experts that can guide them to explore what is out there for them in the world, in the sense of how early can we engage the children in such activities and building their capacities in such fields? Who would like to touch on that? Capacity building for children. Whose expertise is that? Stephen,
I'm no expert in
come
it.
in.
Yes,
Please,
thank
come
you.
in.
So,
Yeah.
good question. And it's public engagement is something that STFC sees as very important, and we do have a lot of resources on our webpage about how to engage with the public and schools, and we do a lot of work and support a lot of work for our scientists to engage with schools, because we see it as very important for science in general, not just for astronomy and particle physics, etc. So I would encourage you to look on the STFC webpage. I can just pop in the link actually in the chat, so at least it'd be a starting point. But we do have a lot of material that you could have a look at. But very much so, it is important that we engage people at all ages to encourage and excite them about the prospect of science and to see the prospect of potential career in science as well. So I'll just post the link in there and have a look at that information. Thank you.
Thank you for posting the link and thank you for your comment. I think Dr. Giovanna and Dr. Ala would like to come as well. So starting with Dr. Giovanna.
Just wanted to add that with Jonathan here, we have started years ago a very successful program that was connecting to a satellite we are building as part of a commercial company. But this program was called Orbits, is called Orbits, because it's still going on. And this program was matching young pupils from secondary school with PhD students, typically UCL, but also from our London schools. And basically, PhD students were working on some real research programs with the young pupils. And at the end of the program, that nobody was lost in about one winter, they can actually publish a research paper if the pupil have been engaged and have produced some scientific results, and really many peer-reviewed, many publication in peer-reviewed journals were published with the participation of the schools and the school pupils. So I don't know if Jonathan wants to add anything, but certainly Orbits has been a good example of a possibility of engaging with young students.
Yeah, the Orbits program has been extremely successful. Personally speaking, I published 5 papers with school students, and now there are quite a lot supporting the Future Aerial and Twinkle programs with exoplanet ephemeris going on. We very much aim the program at schools where it is not traditional for the students to take science, technology, engineering or medicine careers. So whereas we get approached by a lot of schools to do it, we try to focus on those schools that the students don't normally think in terms of studying science and related topics at university. And I think there's quite a lot of evidence to show that we've had quite a transformative effect on a number of these students in terms of changing their aspirations for what they're going to do after school. So I'll be very happy in another forum to share with that and get some of the other people who are. Giovanna and I have provided a lot of the problems, and I think been some of the inspiration for the program. I don't think we've done that much of the day-to-day running of it, so we'd be very happy to put you in touch with the people who have done that. The Orbits program actually won a national award last year in the UK for student outreach in schools. Yes, exactly. Thank you.
This is brilliant. Thank you so much. I can see the excitement on Lama's face, and you will be more excited to hear from Dr. Ala Azam, because from what I saw today coming to the AstroJo Institute, we have a wide range of ages being tapped into here at the Institute. So Dr. Ala, please.
In fact, it was Jonathan. When I was his student, it was my first time to see a school student with us working in real research. Because of that, when I came back to Jordan, it was the idea that we can begin with a student. It is from Jonathan. We can begin with a student. Because of that, since I came to Jordan, I began working with the students even from 11 years old. Okay, if she was asking about the age, we here in AstroJo, we begin with students from 11 years old to work with them on programming and space science, because the idea is that all the children now we are living in an era that the children are very talented in technology. And this is the tool, this is the real tool. So now it is the, let us say, the, what to say, the specialized people is their role to talk to the children about huge concepts and big concepts, to teach them about the science. Then to these children, they have the tools to use it for this science in any time, we don't know. So the idea is to speak with them with the huge concepts.
Thank you, Dr. Ala. We have also Dr. Afar raised his hand, but very quick question for Jonathan in the chat bar on the access to the Royal Journal Astronomical Society. If you can address that in the chat, that would be really helpful. So, Dr. Offer,
yeah,
just like to comment on bringing children into this field.
Yeah, so we focused about engaging children in astronomy and physics, and that's great. But another route is to use data science broader, in a sense that data science is quite a universal language, right? And there could be projects which are more related, say, to the humanities, which could attract individuals who are maybe less interested in the physical sciences, but more interested in text recognition, for example, or image recognition. In fact, Konstantina in her presentation mentioned she worked with ASOS about, analyzing text, right? That essentially AI can read text and understand if a customer is asking a question, and we can use the same tools to analyze, a textbook or a poem or some emails. I hope there will be some one day that AI that can answer all my emails. This will be absolutely fantastic, right? So I think we can approach children in a much broader way, and some of them may want to use it for physical sciences, astronomy, particle physics, so on. Others may want to use it really for completely different fields, which could be literature, sociology, or medicine. So these are my thoughts, how to keep it broader.
Thank you very much, Ofer. We came to the end of this session, but for those who can stay online, we can open the floor for one more question, especially from the students here. If anyone has any question, any comments, please do come forward. Otherwise, I think this is the end of the session. Huge thanks to the speakers from STFC, UCL, and Dr. Ala Azam from Jordan, especially for hosting us here at AstroJo Institute. Many thanks for the students, and many thanks for my colleague Ala for excellent moderation of this session, and of course for our attendees. Please do keep in touch, and for any collaboration or connecting opportunity, do come in touch with us, and we will put you in contact with UCL and the University of Jordan contacts. We will be happy to do so, as well as they will be happy for that. So many thanks, and inshallah we'll see you in the 5th episode